Hi, and welcome back. So today in this video, we're going to be talking about present value of ordinary simple annuity. I'm going to do a quick example, a very basic one, and I'll show you how the formula is derived. Okay, so let's quickly get into it. So here it states that Elizabeth receives $2,500 at the end of each year for the next 3 years. What is the discounted value today? Assume that the interest rate is being compounded 3% annually. So obviously we know this is a time value of money question, and as with any time value of money question, the first thing we have to do is to draw out a timeline. So when we draw out a timeline, we see that Elizabeth's the money that she's going to receive is at the end of each year and it's for the next 3 years. So that's why it's 2,500 at the end of year 0, beginning of year 1. Similarly, 2,500 again, and then 2,500 at the last in year 3. Now the interest rate she's going to be receiving, or the interest rate the money is going to be compounded at, is at 3% compounded annually, and it's for the whole 3 years. So now what we can do is simply use, now we know that it's discounted value, right? So what we can do is simply use the present value of compound interest formula, which is present value is equal to future value times 1 plus I to the power of negative n, to solve for each $2,500 and discount their present value to year 0 or today and see what the value is. And when we discount each one of them, all we have to do is just simply add them. Now we'll start in year 0 where your n equals 0. As there's no investment here, we don't really need to calculate a present value for this one. So at n equals 0, we're not going to calculate any present value. But at n equals 1, which is our 2,500 in year 1, we're discounting it for 1 year, so 1 period, from year 1 to year 0, it's 1 period. So we're going to discount it for 1 year. It's 2,500. The interest rate is 1 plus 3% to the power of negative 1, which is your n, and you're going to get $2,427.18. So that's discounted for 1 year. Now, when we discount it for 2 years, because from year 2 it's 1 year and year 2. So if we get to today, it's going to take 2 years. So if we discount the present value for 2 years, we're going to get $2,356.49. And lastly, if we discount 2,500 for 1 year, 2 year, 3 years, so 3 years in total, so where your n equals 3, we're going to get $2,287.85, right? You were using this formula in each of the 3 cases. And therefore, the total value of Elizabeth's money that she's going to receive for the next 2 years, the discounted value is $7,071.52. So we've practically solved the question, right? Now although it's a annuity question, we use the compound interest formula to solve it, right? Now we've done it, so now we're good to go. But now just imagine that if Elizabeth was investing this money for 10 years or 15 years, it would be really hectic for us. It wouldn't be ethical, right? It wouldn't be right to just go and do each 2,500 times 1 plus I to the power of negative n, to all the way up until 15, do 15 or 30 calculations and just sum it up. That's not right. That would take forever. So what we can do is, obviously we see that this is a geometric series, so we can use the geometric series equation and we can simply solve for present value. Now I've already used the geometric series equation to form the future value of annuity formula in my previous video. You could check that out. I'll leave the link in the below. So I'm going to use my future value of annuity formula, and I'm going to show you how you can use that to solve for the present value of ordinary simple annuity formula. So we know that our future value of ordinary simple annuity formula, we arrived at this in a previous video. You can check it out. So we got this, where we got PMT into 1 plus I to the power of n minus 1 divided by I. This was generated using the geometric series. So we got this. Now all we have to do is this future value substituted into this equation in for the future value here. So if we do that, we have PV as is. Instead of future value, we're writing this form of future value of annuity, which is PMT into 1 plus I to the power of n minus 1 divided by your interest rate, which is your I, times that by the same thing from present value, 1 plus I to the power of negative n. So you've got this. Now, this is technically your present value of annuity formula, right? But sometimes we can make this thing more simpler, right? We can simplify this even farther because there's so many variables here. Sometimes, when you're doing a calculation, then we have an extra step to do. There's a chance that you could make a mistake. So why not just make this equation a little simpler? And what we can do is just take this 1 plus I to the power of negative n, multiply each of the top terms, because the multiplication relation, the brackets, we could just multiply each of the top terms with 1 plus I to the power of negative n. And let's see what we get. So what we get is 1 plus I to the power of n times 1 plus I to the power of negative n minus 1 times 1 plus I to the power of negative n. So what we're going to get is your 1 times 1 plus I to the power of negative n is just going to become 1 plus I to the power of negative n, because 1 times any term is equal to itself. That's why you have 1 plus I to the power of negative n. Now, this 1 plus I to the power of n times 1 plus I to the power of negative n, since they're in multiplication relation, and since both of these terms have the same base, what we're going to do is add the exponents, right? So we're going to add n minus n, right? So n minus n is going to give us 0. So technically, they're going to cancel out, and we're going to have anything to the power of 0 is just going to equal 1, right? So these two terms are going to cancel out, and anything to the power of 0, we know that equals 1. So therefore, our new formula states that its present value is equal to PMT, which is your payment, multiplied by 1 minus 1 plus I to the power of negative n. So that just comes from there, divided by I, and that comes from there. And 1 to the power of 0 is equal to 1. So that's why we have this one here. Now, let's see if we can use this present value of annuity formula and solve for this question here, okay? So let's see if we can do that. So again, it's the same question. We have a timeline from year 0 to year 3, 2500, 2500, 2500, 3% compounded annually. Now, we're going to use the formula. So what we're going to solve for is our present value, which we don't know what it is, right? Now, we know that she's going to receive $2,500 at the end of each year. So that's your payment, the payment she's frequently receiving year after year. That's your payment. So that's the $2,500. So 1, 2, and 3. So you're just going to write it once because it's only here, applied here once. So it's just $2,500 that she's going to receive. And the interest rate is 3%, and it's compounded annually. So your C per Y, compounding per year, is equal to 1. As well as your n is equal to 3. Your number of terms is equal to 3 because she's looking for 3 years, and it's compounded annually. So now what we can do is just simply take these variables and just simply plug it into this equation, and then we should be able to solve for the value. So then we have the 2,500 as payment, 1 as is from the equation, 1 plus I, your interest rate is 3%, compounded annually, to the power of negative 3, that's your n is your 3 is your term, divided by 3%. Now, with any algebraic equation, the first thing you do is BEDMAS, the brackets, and the exponents. So we're going to solve this top part of the equation first. When we do that, we get 0.08485834065. When we get this, we're just going to divide that by 3%, which is going to give us 2.828611355. And then we just multiply this by 2,500. And we get $7,771.52, or 53 cents approximately, right? So you could try rounding error there. So what we can say is that the discounted value of the $2,500 that Elizabeth's going to receive for the next 2 years is equal to $7,071.53 today. That's it for this question. I hope you liked this video. If you did, please give it a thumbs up. If you have any questions, please write in the comments below. And I would appreciate if you subscribe to my channel for more content. Thank you. Have a nice day.